Assume that what we can see on the graph below is the entirety of the function f. So in other words, there is nothing past the edge of the axes. We're looking through that window, but we've been told there's nothing interesting past the edges of the window. So this graph here is the entirety of the function f. Now we want to estimate the domain and range of f from the graph. Now remember, the domain was everything that can be input. So if we go to, say, 0, well look, hey, 0 shows up. 0 shows up in the graph. Well, what about -3? Well, -3, hey, -3 never shows up in the graph. There's nobody that it gets graphed to. Nobody gets output as. So it looks like the edge is -2. It looks like -2 is the very edge. And over here, 3 gets put in, 4 doesn't get put in, but it looks probably like 3.5 gets put in. So we'd say that the domain is going to go from -2 to 3.5. What about the range? So range is everything that can be output. So is there anything that can output at 1? Yeah. 1 manages to touch here and manages to touch here. So there is some input that spits out 1, right? If we put in an input here, we can see that it connects here. But if we go to 3 and we cut across, 3 horizontally never touches the graph, so it must be the case that there is no input that produces 3, so 3 is not in the range. The highest that we managed to get to is right here, so it looks like 1.5 is the highest that we managed to get to with the graph, right? It never shows up over here, but that's okay because it shows up somewhere. And then finally, it looks like the lowest we managed to get to is -2. So our range, the lowest location on our range is -2, and the highest location that we managed to make it to is 1.5, and we hit everything in between, right? If you go to any higher location in between, it shows up. So our range is everything in between -2 and 1.5 because all of them have something that they're able to contact. Great. All right. Hope you've understood what's going on here. Hope it's like really crystallized the idea of a graph. Graphs are so important. They're going to show up in so many things in math, and they're also going to show up in science. And even if you just look in a newspaper, graphs make up a really, really big part of mathematics. So it's really important that we understand what's going on with them now because we're going to see a lot of them as we go on. All right. We'll see you at Educator.com later. Bye.